morning, everyone, and welcome. We're so glad you could join us today for this important and timely conversation on dementia, brain research, and brain health. Whether you are here as a caregiver, a health professional, or simply someone interested in keeping your brain sharp as you age, you are in the right place. Over 1,600 people have registered for this event, and we know that we have folks from all parts of Washington and across the U.S. joining us today. To test out the chat function, please drop a note in the chat box to let us know where you're watching from. Today's webinar is brought to you by AARP Washington, dedicated to empowering people ages 50 and older to choose how they live as they age. Here in Washington, AARP is deeply engaged in advocacy, education, and community outreach, working to improve the lives of older adults and their families across the state. As we all know, brain health is a growing concern. As people are living longer and with dementia affecting millions of families, there's growing interest in understanding how the brain functions and how we can protect our cognitive well-being. Thank you to the Allen Institute and the UW Medicine, Memory, and Brain Wellness Center, who are partnering with us to bring you today's event, and to BECU for being a sponsor. Our moderator is Amity Idrisi, a Senior Communications and Media Relations Specialist at the Allen Institute. Amity, thank you for hosting today. Let's get started.
Hello, Marguerite, and thank you so much for having me. And to everyone out there joining us, welcome. Welcome to this very important discussion, discovering the science of the aging brain. Now, today we're going to be pulling back the curtain on some of the incredible intricacies of neuroscience and reveal how this knowledge is unlocking new understandings, sparking innovative treatments, and making striking new discoveries through research. So we're also going to be giving you some practical, actionable steps that you can take right now to safeguard and enhance your own cognitive well-being. So I want you to take a moment and consider a very startling fact. As Marguerite mentioned, many people are struggling with brain disease. More than 3 billion people worldwide currently grapple with some form of brain disease. So now looking ahead, the numbers tell us that as a global population, as we age, the challenge of brain disease will only intensify, bringing with it immense human and economic costs. So this isn't just a medical issue. This is really a societal imperative that demands our collective attention. So that is precisely why I am really thrilled to embark on this journey today with truly leading experts, those who are right there in the clinic with patients, those tirelessly studying disease in the lab, and those on the front lines communicating critical insights to policymakers. So get ready to dive deep into the future of brain health. Now, before we begin, I want to remind you all that while we're having this conversation, you are encouraged to share your questions, which we're going to get to after the speakers finish their presentations. Also, if you're having technical issues, don't feel bad about it. We all have tech issues. Look under the tech support tab, which is in the upper right-hand corner of your screen, for the most common questions. And if you can't find your answers there, well, then share your tech question in the chat box. All right. Now, with that, I want to introduce our very distinguished panel. Please welcome Justin Miller from the University of Washington Medicine Memory and Brain Wellness Center. He is a board-certified clinical neuropsychologist with clinical focus in adult neuropsychology, geropsychology, and rehabilitation psychology. From the Allen Institute, Ed Lean, PhD and senior investigator. He is also an affiliate professor in the departments of neurological surgery, laboratory medicine, and pathology at the University of Washington. And Sarah Locke, who is Senior Vice President for Policy and Brain Health in AARP's Policy, Research, and International Affairs. She also leads AARP's policy initiatives on brain health and care for people living with dementia, including serving as the Executive Director of the Global Council on Brain Health. Thank you all for being here. Well, Dr. Miller, we thought it best to start with you sharing your experience right now in clinical settings. And with that, I turn it over to you.
Thank you very much for that introduction. It's a pleasure to be here. And I'm happy to start and get us going today with an overview of really the clinical syndromes that we associate with Alzheimer's disease and related dementias. And we'll talk a little bit about some of the prevalence of these conditions and really what things are as they change over time. Now, I'm a clinician and I'm part of a multidisciplinary team at the Memory and Brain Wellness Center. I'm also a researcher and professor of medicine in the Department of Neurology. And what I want to start with to kick us off is really to frame what exactly is neurodegenerative disease and how does that differ from the clinical syndromes of MCI or mild cognitive impairment and dementia. Now, neurodegenerative disease is essentially a process of accumulation of abnormal proteins or other pathologies in the brain that rob it of its ability to function as it should. And these changes often occur much earlier in the life course than we typically anticipate than the clinical syndromes that emerge later in life. We often think now about neurodegenerative disease like Alzheimer's as a disease of middle adulthood that manifests its symptoms in older adulthood. That pre-symptomatic phase before all of the symptoms emerge can occur anywhere from 10 to 20 years before we start to see symptoms. And once they emerge, that clinical syndrome averages around 8 to 10 years. What I'm going to focus my portion of the presentation on is that clinical presentation, mild cognitive impairment, what that means, and then dementia and what that means and how it differs from MCI and normal aging. So to begin, let's talk a little bit about mild cognitive impairment. Now, this is a term that many of you may have heard of. Many of you may have not heard of this, or MCI for short. And this really comes down to a very simple definition. Mild cognitive impairment is really a clinical syndrome. This is what we see in our clinical settings. These are the diagnoses that we often render for patients who have demonstrated evidence of cognitive impairment on objective testing. This is where my role as a neuropsychologist becomes central to care and management for adults and older adults. We look at things like attention, we look at language, memory, and problem solving. And through standardized testing, we identify where is an individual's ability relative to similarly aged adults. We know that there's changes in thinking and memory that occur naturally as part of the aging process, but for some people or in some circumstances, like in the presence of neurodegenerative disease, those changes happen sooner than we expect or faster than we anticipate. And so when there's evidence of these cognitive impairments, whether that's in memory or any of the other domains, that's the immediate question that brings into question, is there something more progressive here? When that individual is still able to function independently, though, they're still able to cook, they're still able to drive and manage their finances, their home is well taken care of, they're managing their medications, even though they have these cognitive impairments, that's really what mild cognitive impairment means. It's this intermediate stage between normal aging and dementia. In terms of other symptoms, though, the other thing, we often focus heavily on the cognitive changes, but it's also important to realize that we now know that there's a lot of other things that are co-occurring alongside these cognitive changes. Things like anxiety, depression, irritability, and agitation. These mood and behavioral changes are also common. And particularly for individuals who develop these symptoms where they're kind of a pervasive and enduring set of symptoms that show up after the age of 50, for someone who's never had any prior history of these types of symptoms, no history of depression or anxiety earlier in life, we often now recognize that that might be a precursor of emerging neurodegenerative diseases that might be unfolding. And so we now look comprehensively in a clinical setting at both cognition and mood and behavior to really try and understand a holistic and big picture approach. In terms of prognosis, well, what does it mean once someone is diagnosed with MCI? Well, about a third of people who receive a diagnosis of MCI at some point within 5 years will progress to develop dementia or Alzheimer's disease. But I want to take a minute and just kind of flip that statistic on its head a little bit and highlight that about 2/3 of people won't go on to develop dementia. Many individuals who are diagnosed with MCI will actually remain at that sort of MCI stage where they've got some challenges, they've got some impairments in cognition, but they're able to maintain their daily living, they're able to live their lives without much difficulty. And interestingly, we also now know that up to 25% or a quarter of people will actually revert from having those cognitive impairment, and their cognition will actually go back to normal. And there's a number of factors why this might be the case, but we start to look as clinicians at what are the modifiable factors that might be contributing to this. These are things that are present in an individual's overall life that might be impairing their ability to function at their best. It might limit their cognition or interfere with it in some way. Things like medication side effects. There's a lot of medications out there that have very powerful therapeutic benefits, but also sometimes have undesirable side effects on our ability to function at our cognitive best. Things like substance abuse and misuse, excessive alcohol take, or recreational substances can also interfere with somebody's cognition, particularly when it's a chronic habit. Sleep disturbances are also important. And so these are all things that when a patient comes into my clinic, we're going to start to look to try to unpack how much of this individual's difficulties in day-to-day functioning might actually be due to some of these modifiable factors, so that we can then treat those conditions and so that we can remove those influences. And for some people, that might be all it takes, and they go back to living their life as a cognitively normal individual. But what happens when it doesn't? What happens when people progress then from MCI into the more advanced stage of dementia? Now, what I want to start with is to highlight that dementia is really an umbrella term. A lot of people equate it or think it's synonymous with Alzheimer's disease, and that's not really the case. Dementia is really a term that describes a very specific clinical syndrome of signs and symptoms that we see. The leading cause of dementia is indeed Alzheimer's disease. We also see vascular diseases and cerebrovascular changes that can cause dementia. There's other rarer forms, dementia with Lewy bodies, frontotemporal dementias, that all collectively lead to this clinical syndrome of dementia. And really the key distinction of what dementia is the biggest difference is that there's now impairments in daily functioning. So just like with MCI, where you've got impairments in cognition, whether that's memory or attention or whatever that might be, those impairments have now reached the point where they're starting to cause problems in an individual's ability to carry out their daily activities. So they might be having trouble remembering their medications or trouble remembering appointments. They may not be safe in the kitchen or forgetting ingredients in familiar recipes, or having more trouble with things that used to be automatic to them. When we start to see that in clinic, they've got these cognitive impairments and they're causing problems in daily life. That's really what dementia means. And then the next questions when I see someone like this clinically is to try to understand, well, what might be causing this dementia syndrome? And so that's where we start to think about things like biomarkers and looking comprehensively, which we'll hear about later. But in terms of prevalence, just to put a few numbers to this, right now, the latest estimates are that there are around 6.5 to 7 million people living with Alzheimer's disease. And the problem is continuing to get worse. Since 2018, the deaths due to Alzheimer's disease have increased by over 140%. And now over 1 in 9 adults over the age of 65 they have Alzheimer's disease. And as you look across older and older age groups, 75, 85, that number increases. We also now know through decades of research that there's a much higher proportion of women that are affected by Alzheimer's disease. And it's not only because women have to typically live longer. We also know that there's increased risk for Black and African Americans and non-Hispanic older adults relative to non-Hispanic whites. And individuals living in rural communities outside of major metropolitan areas have been also shown to be at increased risk for developing dementia. And one of the other things I want to highlight with this is these statistics are based off of the people who have dementia due to Alzheimer's disease that have come into a clinic, that have gotten confirmation, they've gotten diagnostic testing. But the actual prevalence may be much higher because there's people who have amyloid in their brain, the key protein associated with Alzheimer's disease, that don't develop any symptoms. But these aren't the people who typically come into clinic. These aren't the people who typically come into research settings. If you can't get to a specialty clinic, if you live in an area where you don't have a sophisticated institution like University of Washington or the Allen Institute where you can get the access to the diagnostic services, your risk of going undiagnosed or underdiagnosed is high. And so when we talk about prevalence, yes, it's a big problem. I would also argue, and I think many others would as well, that it's much more prevalent than what we realize. So what do you do about it once diagnosed? Well, up until 2021, everything that we had in our armament of treatments really focused on symptom management. The only drugs that had been on the market were cholinesterase inhibitors, things like donepezil or galantamine, which treated some of the symptoms. For some people, they slowed progression, but they didn't do a whole lot to actually treat the underlying disease process. And nearly every clinical trial done up until 2021 had failed. That all changed with the approval by the FDA of these new medications, aducanumab, lecanemab, donanemab, which these are really groundbreaking discoveries that have come on the backs of decades of federally funded NIH research and institutional research that came up with these drugs that are monoclonal antibodies administered via an infusion that target amyloid. And in these clinical trials, we've seen improvement in cognition and we've seen a reduction in amyloid burden in individuals on treatment compared to those who weren't on treatment. So this is really important because now we actually have disease-modifying therapies available. The challenges with this are that these medications require confirmation of the presence of amyloid in the brain. And historically, that had to have been done through a CSF study or a lumbar puncture, which is painful and can only really be accessible in a specialty clinic. And then more recently, we've had PET scans to look for amyloid in the brain. But just within the past few weeks, for the first time, we now have an FDA-approved blood test for Alzheimer's disease. And this is a remarkable, groundbreaking change in discovery that really is going to increase the access of these medications to help us identify who really is going to be eligible for these medications. Right now this test is limited for patients who come up to a specialized care setting who have complaints of cognitive decline. But this blood test is highly accurate. And to put it as in the words of some of my esteemed colleagues, it is truly a groundbreaking discovery. But I'm going to conclude just really quickly to talk one more time about, well, what do you do before you get to that stage? And we're going to hear a lot about this in a little bit, but just to set the stage a little briefly, I want to talk about prevention. One of the things that we now know, or at least believe to be the case through large-scale research and ongoing projects, that we estimate that up to 45% of cases of dementia, this is more broadly than just Alzheimer's disease, but 45 cases of dementia may actually be preventable through modifiable risk factors, things like lifestyle changes and other habits. And interestingly, remember in the beginning when I started and said that this is a disease of midlife that shows up with symptoms in late life, we now know that the influence of lifestyle changes has become more focused on this midlife experiences. Right now, in the 2024 report, the estimate is that up to 30% of your risk for developing dementia can be reduced through these midlife changes. And particularly this week, a large paper was published looking at over 40,000 individuals to show that in specific, managing hypertension and high cholesterol, diabetes, and smoking had the greatest influence on that late life risk for dementia. And so this is a big area of emphasis and thrust of my work and that of my colleagues to try to understand the mechanisms of how these risk reduction and lifestyle factors influence risk for developing dementia, understanding the underlying biology of how these changes unfold. And it's really important to highlight that, all of this work, all of the drugs available, the progress we made in clinical care is directly linked to our dedication to medical research and biomedical sciences. University of Washington is committed to improving the health of all people, and we do that in a big way through research. If you'd like to get involved and learn more about our aging research or other brain health initiatives, please scan this QR code. Happy to share more information with you. Sign up for some of our projects. And with that, I'm going to conclude, and I'm going to turn things over to my colleagues for continued discussion of the underlying biology and some of the other brain health work being done through AARP.
Justin, thank you so much. That was very insightful. I feel like you were looking at me, midlife changes. We're all going to be working out later today. But you did mention something very important, that of research, because really that is what we have been focusing on so much lately. And that's what we focus on a lot at the Allen Institute. And when we talk about therapies and treatments, we have to find the next generation of cures. So here to share some of the cutting edge research that is happening right now is Ed Lean of the Allen Institute. Welcome, Ed.
Thank you very much. It's really a pleasure to have the chance to speak to all of you about some very rapid progress that's going on in understanding the human brain in health and also in Alzheimer's disease. I'd really like to spend this to tell you about some advances that are being made, both on the foundational side of trying to better understand the human brain in health, as well as trying to understand at a much more detailed level the consequences of Alzheimer's and related dementias and what happens to the brain at a very fine level of granularity. And this has really been supported by two big consortium initiatives, actually international consortia that were supported by the National Institute on Health and National Institute on Aging, and really trying to bring some foundational work from the National Institute of Health Brain Initiative to understand Alzheimer's disease better as well. I'd like to step back though a little bit though to begin and really kind of cast the nature of the problem that we're facing. And as Emily said at the beginning, we have this astonishing statistics that about 1 in 3 people suffer from some tragic neurological condition. And this has now become the leading cause of disability and ill health in the world, in part because we're having success in treating most other disorders, but disorders of the brain really remain this grand challenge to solve. And a large part of why this is a challenge is that we have a very poor understanding of the human brain, both in health and disease. And the consequence of this is that we don't really understand disease mechanisms well in the sense that we could actually lead to very precise treatments. And so most of our diagnostics and our treatments remain extremely coarse. There are also societal issues about data sharing to allow progress to happen extremely rapidly. And the consequence of this is that most of the things that go through the clinic are actually failing, with a few notable exceptions, as you just heard about. But really, this needs to be improved. And one way that this can be improved is by treating the brain as a cellular organ. This is really important because, like every other organ, the brain is made up of cells. And these cells form the functional networks. They're the basis of disease mechanisms and genetic risk, for example. And I think we can all understand that if you want to treat a system, for example, treat a cell phone that's broken, it's important to understand the components. If you don't understand the components, it's very hard to understand what's gone wrong or how one might treat the disease. So understanding this at the level of cells is a very fruitful way to go. But here we have a huge complexity problem with the brain. The brain is extraordinarily more complex than other systems. It has about 100 billion neurons. We now know that these come in thousands of different varieties. Before we even think about the circuitry of the brain, neurons make connections to other cells in different parts of the brain. And so they don't act just locally, they act at distances. And so you put this together and you've got a system that's several orders of magnitude more complex than other organs. And we have extremely limited access to study it in the human brain. This leads to huge gaps in our knowledge. We don't understand what all the types of cells are. We don't understand how they're connected. We don't very much understand which types of cells are vulnerable in disease or affected by disease that might be treatable. And so we often find ourselves trying to search for model organisms to study the disease without actually understanding how closely related those models are to what we're trying to study. So the NIH Brain Initiative has really recognized this problem and has put a major investment through the Brain Initiative Cell Census Project into trying to get a comprehensive understanding of the cellular makeup of the brain. Through two major phases of this. One was called the Brain Initiative Cell Census Network, or BICCN, another called the Brain Initiative Cell Atlas Network, or BICAN. And these really tried to bring together some of the top laboratories in the country to work together towards understanding first the brain of a model organism, a mouse, and then translating this up to understand the complete structure of the human brain, which is now happening through this BICAM project. The key thing that allowed a major advance in this field is a technology that actually came from a different field. And that is a technology called single-cell transcriptomics. So probably most of you know that, that every cell in your body has the same genome, it has all the same genes, but each cell only uses a subset of those genes. And it does so by making a copy of the DNA into an RNA called a transcript. And the complete set of those is called the transcriptome, just like the complete set of genes is the genome. And we can now measure those in individual cells, and we can do this across now millions of cells. So you have this huge amount of information per cell. Now you can group cells by their similar patterns, and you can create a classification of cells across different parts of the brain. And this turns out to be extremely effective. We can make a very detailed understanding of all the types of cells, the neurons, the non-neuronal cells, down to the incredibly fine level of granularity, and then start to add information about this. So it becomes very much like the genome, where you can define the cells just like you can define the genes, and you can start to understand the properties of those cells. And in very, very rapid succession, because these methods are so scalable, we've been able to go from a mouse to a human and start to get the first draft of the cellular makeup of the entire brain. And now this is being done at a much finer level of resolution to get a very detailed, complete coverage of the entire brain. This is really the equivalent of the human genome, the human brain cell atlas. Now, once we have this classification, you can start to add information. And this is kind of a remarkable story of how one has to go about doing this. To gain access to the properties of cells, you have to look in living brain tissues. Those tissues can only be obtained from donations from people who have to have part of their brain removed to treat epilepsy or to remove a deep tumor. They can donate those tissues, and we can use those to understand the anatomical, the shape, the morphology, the physiology, the function of these cells, and add that information to this classification. But this is an extremely active process of donors that generously donate their tissues to allow this to happen. Now, why is this important? Once we have this reference, this classification, we can use it now to study disease. And so I'd like to spend the second half of this describing how we can use these technologies and this knowledge to better understand mechanisms of Alzheimer's disease progression. And these methods, as I've been describing them, can be applied to Alzheimer's brain tissues from donated brains to study what types of cells and what genes or molecular pathways may be affected over the course of Alzheimer's disease. And so more sort of colloquially, we can think about what types of cells, the what, where are they located, and when across the course of disease. And we can now get a very fine-grained understanding of which types of cells may be selectively vulnerable. Not all cells will be equally vulnerable. Can we model this as a trajectory? Can we understand what genes are disrupted? That might provide a whole new set of targets, both the cells themselves and the genes becoming potential new targets for therapies. And I'd just like to highlight, as we talked about amyloid in the last talk, and this was really the genesis of understanding Alzheimer's disease as a pathology-based disorder. Amyloid is one way of looking at it, but it really doesn't pay much attention to the structure of the brain and specifically what's being affected. And so now we've kind of gone from this proteinopathy as understanding of a gene that's disrupted to looking at hundreds or thousands of types of cells measured across the entire genome. We have this incredible resource now to better understand what's happening in a detailed fashion. Of course, this is way more than anyone can, even a very well-resourced institute could study themselves. And so it's important to make these as community resources. And that's the intention of the Seattle Alzheimer's Disease Brain Cell Atlas Project, is to create this high-quality resource and make it available as a community resource. Any of you can access this. This is an open resource for discovery and mining. I'd like to highlight just a few points, though, that a few results from this that I think are particularly interesting. By modeling across the spectrum of disease, we can understand which kinds of cells are affected, which cells are lost. And ultimately, in Alzheimer's disease, neurons are, of course, lost, and certain kinds of non-neuronal cells get into a pathological state. So we can see decreases in different kinds of neurons, and we can look at which kinds of neurons are actually the ones that are affected. Not all neurons are affected, but specific types are. For example, here, in the box on the top, you can see decreases in some of the excitatory neurons that make connections from one part of the cortex to another part of the cortex. And we now, from the living surgical analyses that I described, we understand something about these cells. We know their shapes and their properties. But even more interesting, if we model the progression of disease, we can see that those cells are actually lost very late, whereas other cells are lost very early. And in particular, some inhibitory neurons, very specific types of inhibitory neurons, turn out to be the earliest, most vulnerable neuron populations lost, well before there's a lot of pathology that might be detectable with a blood test, for example. And so these now present new targets and a new way of thinking about the disease as well, as not as a disease of a protein, but as a circuit disorder where certain types of neuronal circuit elements are lost, and this may cause a cascade of events that ultimately leads to loss of other neurons and cognitive decline. Now, this is important in another way, too, that also came from the foundational work of the Brain Initiative. Because we are defining cells on the basis of the genes that they use, we can also understand why they are used in a very selective way, and they're regulated. So we can then identify those regulatory elements and use that as a tool to be able then to selectively target and turn on a gene in any kind of cell. And it turns out that this information is extremely powerful. We can now find such regulatory elements for any kind of cell in the brain or the body for that matter. And this can be combined with tools that are used commonly in gene therapy, to viral tools that can be used to target the selective cell and deliver a therapeutic gene. And I'll just leave you with a teaser that those cells that I described as these early, most vulnerable cell populations, we have created tools already that can selectively target those kinds of cells. So you can imagine in the future that if this turns out to be a very robust effect or other types of cells, we can now target them and perhaps we could prevent their degeneration or develop therapeutic strategies around the consequences of their loss. So this is, of course, aspirational. This is well into the future, but I really want to highlight the importance of this basic research to get a very detailed understanding so that we can then develop from that and the community can work from that. Without this kind of work, we're unable and we have to work only with what's been done in the past. And finally, just like to really highlight that this type of research is critically dependent on brain donation. And like any other system, we can only work with brains that are donated in an active fashion. And there are many opportunities for doing this. This is not part of organ donation. There are opportunities, for example, through the Brain Donor Project at the University of Washington. The Brain Lab is actively recruiting individuals to participate in research and then allow us to try to connect the function of the brain with this deep cellular organization of the brain. So with that, I'd like to end and really thank the many, many people that are involved in this. These are big team open science projects. These projects I've described have been led by the Allen Institute, but with many collaborators across the country and the world. We're quite dependent on the generous funding from the National Institute on Health and NIA to support this work, and also, of course, for many collaborators and brain and tissue donors. Thank you very much.
Ed, thank you so much. Such important work and a great reminder that we can all be involved in continuing that work. Well, as we continue to talk about research, I want to turn things over to AARP's Sarah Locke, who actually has some very exciting news to share. AARP has just released a new study with the Aspen Institute on music and Alzheimer's. Sarah, this is really exciting stuff.
So I'm so excited to be here with all of you to share this information and give a little background about how we got to where we are on this research. But I have to say the information that Ed and Justin provided are really, really exciting, and I was thrilled to listen in on their presentations and honored to join them in this panel that AARP Washington has put together so well. So thank you for inviting me to talk about discovering the science of the aging brain. It's a perfect opportunity because AARP has been, obviously we are not scientists ourselves, but we have been working very closely and partnering with scientists all around the globe. And I'll tell you a little bit more about that. So that we have the ability to bring the best information to people 50 plus all across the United States and frankly around the world. I want to start by giving a shout out to AARP's research, internal research team. We're constantly surveying people to understand what are the issues of concern to adults and how AARP might be able to best address them. One of the things that our research team over the last few decades has done is ask about brain health issues and perceptions of aging and perceptions of brain health. And through some of that research, we found out that 6 out of 10 adults believe that cognitive decline is inevitable. That, of course, is a really interesting statistic in light of Justin's remarks about people coming to clinic and finding ways perhaps to change the trajectory in the course if they are so concerned about their brain health that perhaps by seeking healthcare, they can even reverse cognitive decline. So it's really important for people to understand that cognitive decline is not inevitable. Well, that's a great message for AARP, right? But what's interesting about this research is we found that the younger you are, the more likely you believe that cognitive decline is inevitable. You know, when you get to be my age, or maybe people in their 60s and 70s, you realize, well, I still got it, so maybe cognitive decline isn't inevitable. But those statistics made us realize that people simply don't understand how much control they actually have over their cognitive function. So we need to get the word out there that cognitive decline is not inevitable. And Justin actually used a statistic of up to 45% of cognitive decline could be reduced through modifiable lifestyle factors. And over the years, the science has just been getting stronger and stronger around the evidence. But imagine if we are able to delay onset of dementia. I would not talk about totally preventing it, but just delay it by 5 years. We can cut the incidence in half. How much better would that be for our society, but just individuals? So the importance of prevention and risk reduction concepts are incredibly important, even if we can't stop Alzheimer's in its tracks. But knowing that with an aging population, it's more and more likely that people will experience cognitive decline because aging is the most common non-modifiable lifestyle factor that increases your risk for cognitive decline. But we have to be able to tell people what steps they should take through midlife and beyond to change that possibility or lower their risk. So adults want to know what works and what doesn't to help them maintain their brain health throughout their lifespan. And so AARP, by constantly surveying our members and talking to non-members in the adult population to find out what are they interested in. Well, they're interested in, do blueberries really work to improve my brain health? What about these supplements that I've been hearing about? How about my cardiovascular risk? How's brain health related to my heart health? These are questions that are incredibly important to adults. So we have, over the last decade, launched the Global Council on Brain Health to bring experts together. And Ed talked about the importance of interdisciplinary sharing in science. Well, that's what we're doing with respect to clinical work and outcomes and epidemiology. And we've brought these experts together to understand what is the consensus around the state of the science on all these issues, so that we can then in turn translate this information into consumer-friendly ways to share these insights. And so over the last years, we've done 14 reports. If you're interested, these are all available for free at the Global Council on Brain Health's website. And we know not everybody has the time or interest of reading 25, 35, 40-page reports, which gives you all of the background, but we distill them into one-page infographics available in 5 different languages so that we can get the most critically important information out to people wherever they may be. And AARP Washington does a great job of sharing this information, by the way. So I wanted to say that when the last published report is around hearing, people don't often understand the critical importance of hearing to brain health. And in fact, it is one of the most modifiable risk factors that people have. Aging is not modifiable. Hearing loss is. By protecting your hearing throughout your lifespan, you're doing your brain a favor. And if you should have age-related hearing loss, which so many older people do, you can actually lower your risk for cognitive decline by improving your hearing. And I would urge people who, as Justin was talking about, going to their clinic to check out causes. Hearing can be a very big complicating factor when it comes to brain health. So we've distilled these issues of hearing and what people can do about it into this infographic and giving you the science in the report. But AARP has great resources available on our hearing at our aarp.org/hearing center to get a free hearing test. And this will give you a baseline to understand, is there something that I need to do? Should I actually take some steps? If you take this free hearing test, it'll let you know whether or not you might have an issue. AARP has many resources available. I talked about the Hearing Center. I will talk to you more about some of these issues as we go. But all of these materials are related. The foundation of the information we are providing is the good science that the Global Council has helped us put together. But we want to make sure that people can get this information wherever they are, anywhere across the United States, or frankly, elsewhere in the world. And so AARP has developed a program called Staying Sharp. It is a digital information program that can be personalized to you to help you understand how the 6 pillars of brain health, what we call these kind of fundamentals of modifiable lifestyle factors that you have a lot of control over, what you can engage in and do to improve your brain health. And finally, our magazines, which I can brag on because as I get ready to leave AARP after 27 years, I can brag on my great colleagues' work. AARP has the largest circulating publications in the world, and that information is backed and supported by the great science that we are able to bring together on behalf of AARP members everywhere. So we have been surveying our members now for quite a while, and when we ask people, hey, do you think brain health is important? 98% of people 40 and older say, yeah, it's very important. I've always wondered about those other 2% and why they don't think that it is. But we also ask, are people doing those things? Are they living the healthy lifestyles, the exercise, the right kind of diet? And 56% say they are. And we know they are lying because we know that people do not exercise as much as they think they do. And their diets are not as good as they say. Now, of course, there are a few great people who have maximized their health, their healthy living. But for most of us, we can all find ways to improve our lifestyles and choose healthy lifestyle activities and behaviors that can promote our brain health across the lifespan. So the two barriers that stop most people from doing this, not knowing what works and the people around you. Well, that makes sense, because if your friends and your family are doing things and exercising together, you're likely to do it. And if the people around you are eating and making healthy choices, that can be very supportive of your making those same kinds of choices. But we know that's not enough. We need to have everybody in the world understand that we have a tremendous opportunity to help each other and to help ourselves build better minds together. So our campaign that AARP has launched is around behavior change. It's a multi-year strategy that is designed to energize all of us to choose brain healthy lifestyles. Now, if you're on this call today, chances are you've already bought into the idea that you can improve your brain health, or that you're interested in doing it. But a lot of people still, remember that number of cognitive decline, 60% think it's inevitable? We need to reach lots of people to change their minds and attitudes around this issue. And to remove the stigma and this hopelessness. Oops, I see, I'm just about out of time. So let me speed through and tell you a couple of things, because I really want to get to the exciting report that Amity, you led into, which is we've done an economic analysis along with the Aspen Health and the NeuroArts Blueprint to take a look at the impact. Can music have a beneficial impact on people's brain health? Well, we know from the science that it can, but just how much? And is it a wise idea to get payers to think about finding ways to include music therapy as a way of helping ameliorate some of the symptoms of disease? Do we have time to show the video?
This is AARP Policy Now. A quick take on the latest policy issues most affecting older Americans and their families. With a special edition, Alzheimer's disease and the economic value of music engagement. Did you know that more than 7 million Americans are living with Alzheimer's disease? A new report sponsored by AARP finds there is great economic value in engaging with music for people living with Alzheimer's and their caregivers, to the tune of $5 billion annually. The dollars saved comes from music's ability to improve their quality of life.
The economists at Deloitte, the well-known accounting firm, measured certain metrics like improvements to sleep and reductions in depression and anxiety, improvements in activities of daily living. And then they looked at how these improvements can actually reduce healthcare costs.
It's projected that health and long-term care costs for individuals with Alzheimer's will reach a staggering $360 billion. This financial burden affects not only individuals with the disease, but also their families and society at large.
Things like reduction in emergency room visits, length of hospital stays, reduction in medications, and in some cases, delay or shortening the time spent in long-term care facilities. Caregivers actually feel their stress burden relieved when they can engage with their loved one in musical activities.
The report finds the economic value of engaging in music for 30 minutes, twice a week, for a year may be as much as $5 billion a year in improvements to quality of life.
Music is something that all of us know really makes a difference. We all feel better. When we sing a song, we hear a particular tune. It's something that we all know intuitively makes a difference. We now have the science to back it up, and we now have the economic analysis that makes the case. So, as we as a country confront a growing epidemic, no real cures currently available or on the horizon, Let's turn to a very inexpensive way of trying to help Alzheimer's patients and their caregivers as they continue to take on this challenge.
We now know that every dollar invested in music engagement for people living with Alzheimer's disease results in a return of investment of $2.40. That is a great return on investment. This report gives us the evidence we need that music can be used as a prescription for well-being that helps people and reduces healthcare costs.
To learn more, visit brainhealthaction.org. AARP Policy Now is produced by the AARP Public Policy Institute. This special edition was produced in partnership with the AARP Brain Health Action Collaborative.
Thanks so much for letting me share that video that my colleagues were able to create. And just to say a word more, because I know we're running short on time, the science behind the evidence is not what we did in the report. We were looking at the economic analysis using the science of how that can impact the brain. So here is a very short way. You'll find more details in the report. The biology, the behavior, the psychology, the cognitive and emotional benefits translate into well-being and quality of life measures, which in turn result in the ability to look at the downstream effects. And as you heard in the clip, it depends on what the uptake is for people who are living with dementia and Alzheimer's disease and their caregivers. But you can see what a significant investment. And I just want to say that the science is what enables us to come with these policy decisions later about the effectiveness of interventions. And without the economic analysis, we wouldn't know how to stack rank the various choices that policymakers have. But here we've absolutely established that music therapy and music engagement can be powerful tools in ways of improving quality of care as well as reducing costs. So my final slide is simply to say, here is our available resources. We have lots to offer about brain health in general, beyond Alzheimer's. So I urge you to check out our materials. And I'm going to speed through the rest of my presentation because it is time for me to turn it back over to Amity. But I just want to give a shout out to my team as I leave AARP and say, my colleagues, there are many of them. You saw some of the slides of the scientists behind it. But I want to give a shout out particularly to Lindsay Chura and Dave Parks on my team, who have been with me over these many years as we work to get this information out to people. Thank you.
The AARP has led to such an impact, and I have no doubt you will continue to make an impact as you go on to what's next. Speaking of impact, I know Sarah mentioned about how we really need to reach more people, right? Like this is what we need to do. So I wanted to let you all know that by probably tomorrow, there is going to be a recording of all of this available on YouTube so that you can send this to your friends, your family, your loved ones, everybody, so that they know, what to do, what's happening, how to go forward with everything. And it's going to be at youtube.com/AARP. That's where you can find the recording. Again, I'll just say youtube.com/AARP Washington. I'll mention it again at the end of this. But for now, we want to get to some audience questions. And Sarah, I will start with you because you made me giggle when you mentioned blueberries, because we all do want to know, like, what are the tangible things we can do? And so someone asked, and I'm curious about this question as well. Mara asked, are there brain games that help with brain health? There are a lot of them out there, and it's difficult to know which are really good for the brain.
Great question. And one of my favorites, because a lot of people think that because they've seen the advertisements that if you play brain games, suddenly that is going to prevent Alzheimer's disease. It is true that staying cognitively engaged and using your brain, discovering, learning new things is very beneficial for your brain health across the lifespan. In fact, people build cognitive reserve and cognitive resilience as a consequence of continuing to use their brain. Brain games train you at certain skills, and you get very good at those skills if you get at those good games. But just because you're good at Sudoku doesn't mean that you can manage your finances. So unfortunately, there are no magic bullets here. We encourage people to have fun and enjoy those games. And in fact, Staying Sharp has games available through the platform. But we are not telling anybody that by playing these games, you can prevent dementia, because the science is just not there.
Yeah, I think that that's what's important. And speaking of science, we've got some great researchers here. And I wanted to ask a question to you. Stephanie had asked, has the gene that is connected to dementia been identified? I know we're finding these precursor markers, but she wants to know if the gene has been identified and if it's passed genetically.
Yeah, that's a great question. There are certain genes that are associated with extremely high risk for getting dementia. But a lot of this is idiopathic. It is not clear what the genetic basis is. And most of the genetic forms are really associated with early onset. The ApoE4 allele, for example, is highly associated with risk. And we can see that in population-based studies, whereas some of the things like presenilins have a very high penetrance for early onset. But the majority of cases, we really still don't understand well what the genetic basis is.
Yeah, I think that's hard because, that is what we're trying to track down, right? These are these things that I think people need to understand is so much research needs to be done to get through these different layers. Justin, I want to get to you because this question seems a little bit urgent. So Scott wrote, husband diagnosed with MCI this year. Doctor suggests waiting a year to see how it progresses. Is this wise? Should he be going to a specialist now to prevent the MCI from getting worse?
Ooh, that's a great question, an important one. And don't take this as medical advice because there's a lot of complicating factors that certainly could contribute to this. But it's hard for me to really imagine a scenario where waiting, especially when we're talking about progressive neurodegenerative diseases, would be advantageous. What I tell patients who come into my clinic, and I see hundreds to thousands of people a year, and almost ubiquitously for every single patient, whether they're coming in and they're cognitively normal or they're in advanced stages of dementia, I always tell them, if there's one thing you come away from this visit is you need to be doing more today than you did yesterday. You cannot sit and passively wait because time and the disease is not going to wait for you. So in terms of thinking about, well, what should I be doing? I would encourage proactivity here. And I encourage that even before symptoms emerge, but especially once you start developing symptoms that you've received a diagnosis, particularly now that we've got some therapies, there's things that we can do about it. But in addition to those therapies, also looking at those modifiable factors that we talked about. Maybe there's other factors that are contributing to that cognitive difficulty that aren't due to neurodegenerative disease. And if there are, let's treat those.
Mm-hmm. Yeah. Justin, real quick, before I let you go on this one, I wanted to ask, because a lot of people are asking, what is the name of that blood test? Because I know a lot of you out there might be going, okay, I want to ask my doctor about this. What do I call it? What is the name of it? And also kind of related to that, do disease-modifying therapies actually reverse Alzheimer's, or how does that work?
Oof. Man, you're really hitting the big questions here on this.
Not me, it's everybody out there.
Yeah. Well, okay. So the trade name of the blood test is called Lumipulse. But It's the only one out there. And so it's not the kind of thing that I think you'd have to really ask, for the Lumipulse test. It's really the only option. And it's pretty new. So it's going to be at top of mind, especially for a lot of primary care providers who are going to start getting these questions, especially people in specialty clinics. But what it does is it looks at the ratio of amyloid, beta amyloid, to phosphorylated tau, which are two of the key proteins in the brain. And so the Lumipulse test is the name of it, but really I think you could just go as far as say is, hey, what's the name of that new test available for Alzheimer's disease? A really important caveat with all of this, so that I just want to highlight, because the FDA has approved it, Medicare has not yet issued their position on it. So FDA approval is the first step so that we know that it's safe and it achieves what it says it's going to do. And now the next step is to determine whether or not Medicare is going to pay for it. But, I don't have a crystal ball, but if I were Medicare and I'm looking at the cost difference between an amyloid PET scan and a blood test, the blood test is a heck of a lot cheaper. So we're hopeful that Medicare will ultimately go on to cover this. Sorry.
No, go ahead. Sarah, jump in.
Amity, thanks. Justin, I wanted to jump in only because the Global Council has been looking at this exact question. And my understanding is that there's consensus among the experts that test should only be given in a clinical setting in which there are symptoms. People who are experiencing symptoms are the people who are supposed to, that this test is for, that the FDA, I think, has approved. And is that your understanding?
Yes, that's absolutely true. It's really intended for people who are in a specialty care setting that are starting to show signs and symptoms of some degree of cognitive abnormality that's not normal aging. So yes, that is a very important consideration as well.
Okay.
And Amity, you had asked the second question, and speaking of memory loss, my own memory has failed me.
No, you know what? That's on me. That's on me. No, the question is that do these therapies, these modifying therapies, actually reverse Alzheimer's? And do we even know the science of that, actually?
So yes, there has been a lot of talk lately about reversing Alzheimer's disease, and pretty compelling opinions recently published as well in editorials in some of their national publications about reversing Alzheimer's disease. The short answer is no. The monoclonal antibody therapies that are out there, they are not a cure, and they do not reverse the consequences of amyloid accumulation that have already taken place. So to the best of my knowledge, no, there isn't really anything about reversal available at this point, which really reaffirms and highlights the importance of adopting those brain healthy habits, doing as much as we can through lifestyle and behavioral choices to really try to reduce our risk through behaviors. One of the things we were talking about earlier, if I could, Sarah talked about 98% of people think brain health is important. My goal would be to make heart health, which almost everybody agrees, probably 99.9, maybe there's still 1%, but to make brain health as commonplace in midlife as heart health is.
Yes.
And so that's really something that I think we need to work towards.
That's actually what I've taken away from this event mostly is that we aren't talking about it soon enough. And the incredible discoveries being made, this blood test for one. But Ed, this next question is for you, because I think it's really, really interesting that this one person asked this. This is from Jim. Wants to know, what role do you see artificial intelligence playing in unraveling the complexities of the aging brain, particularly given the massive data sets involved? I figured you would be the best to answer this.
Oh, this is a great question. This science has become an enormous data science, and we're sort of swimming in huge amounts of information that are difficult to understand. They're difficult to navigate. And yet there's enormous information buried in there. And we're seeing incredible progress on using large language model-based approaches for being able to deal with language and plumb the literature. And now this is starting to get applied to biological data as well. This is happening at the level of protein structure, for example. Nobel Prize was just awarded around this topic, and genomics data and many other kinds of data as well. And so there is, a language of the genome and a language of disease that presumably can be teased out by accumulating all this information in these sorts of data structures. This has not yet been shown, but already there are tangible advances on being able to use generative AI and modeling for understanding gene regulation, for example. And I think that a frontier for this is really trying to start to apply these AI methods to understand the relationship between different kinds of information, the relationship as they progress over time, and apply them to disease. And you can imagine in the future that that this will be able to aggregate all of this data, and you can now start to have predictive measures that come out of this, and maybe even individualized predictive measures of the state of an individual along the progression of disease and what their likely prognosis is, and maybe what the best treatment is. On a more immediate side of things, I think AI applied to the study of neuropathology is likely to make big advances in the fairly near future, so that we can better diagnose and stratify patients and things like this. So I think this is really an area to watch. It hasn't quite happened yet, but the marriage of these huge data resources coming from the types of studies I described with the advances on the AI space is really primed now to come together and have an impact in medicine.
Yeah, which is incredible. What an incredible place to be. But it hasn't been easy. It's taken a lot to get here, and we all need to collaborate with each other. And you mentioned collaboration. I think everyone here mentioned collaboration in their discussion. And so I think it's important to remember that this is a job for all of us, lifting each other up. I want to ask this question because I think it's a very, very good question. It really gets down to the basics of things. And this is for any one of you who would like to answer. But Lisa was wondering, when do normal aging changes start taking place? And can you please give an examples of what memory issues may be within normal limits for the decades, i.e. the 50s, 60s, 70s, and 80s? So I guess kind of a way to change this question is, what is normal and when should you be worried?
This is a question that I get very often in my line of work. It's not a clear-cut answer, and this is something that we could talk about for quite some time. So in a nutshell, and in very simplest, if you're experiencing cognitive changes and you're worried about it, or it's impacting your work, or it's impacting your daily life, you need to talk to your physician and let them figure out whether or not, and let them help you figure out if this is truly something that's normal or abnormal. But really at its core, if you're experiencing changes and you're worried or someone else is worried about you, again, time is not necessarily something that you just want to let go by with these conditions. To add a little bit more specificity to it, the question is, when do these normal age-related changes in cognition start occurring? Well, I'm sorry to tell you that they start for some of your cognitive abilities in your 20s. Whether we like it or not, our processing speed, for example, and how quickly we think about information, it peaks, early adulthood, 20s, and then it starts to go downhill from there. But a lot of other facets of cognition continue to improve. And so it's not all bad as we grow older. But to think about the hallmarks of Alzheimer's disease, for example, I like to paint a picture and describe memory as a file drawer. And in order for you to remember something and to learn something over time, you've got to be able to get information into the drawer in the first place. Drawer has to have a nice solid bottom to it so it stays in the drawer. And then you've got to be able to open that drawer later so that you can access that information and pull it out when you need it. Sometimes the drawer gets stuck and someone will say, hey, remember when we talked about, and the drawer pops open and there's your information. Sometimes it's like the drawer doesn't have a bottom to it. And that's the situation where information goes into the drawer. No matter how many times you put it in, no matter how much help you get opening the drawer, it doesn't matter. It's not there. the information is gone. That's the prototypical memory loss that we see in Alzheimer's disease. So you're going to see things like asking a lot of the same questions over and over again and not having any recognition that that information has ever been shared before. Now, in terms of normal versus abnormal aging, I would say 99% of people who come into my clinic can tell me about a time where they've forgotten something. I'd probably go so far as to say even 100% of people. Occasional lapses in memory are completely normal. It's especially in busy lives. You know, you've got parenting, you've got occupations and job demands, you've got social demands, and all kinds of other factors can compete for our attention. And so normal forgetting happens. Word finding trouble. So many people tell me that I can't come up with words, or I forget an actor's name, or I forget such and such, or that is probably one of the most common things that happens just as a normal consequence of aging. And so, yes, there's a lot of decline that we see in subtle changes over time, but it's when it starts to interfere with functioning or cause worry or concern for you or others, that's when you want to seek help.
Mm-hmm. Sarah, I seen you nodding your head. Do you have anything to add to that?
He did a great job, and we have shorthands about it's completely normal to forget where you put your keys, but if you don't know what your keys are for, you know, there are some relative concerns. But the point he was making about if it starts to affect your life and there is a change. If you've always been kind of forgetful, probably not such an issue. But if you used to be able to do something and now you can't, that is a big change. And if others around you are starting to notice things like that, it's time to pay attention.
Yeah. Yeah. It's interesting because I know that we are still just barely scratching the surface of what is causing this. And Ed, we had that incredible paper that you mentioned, CIAD came out, and it talked about those basically early warning signs of what we hadn't expected to see. With something like that, how do we go forward? What's next with that research?
That's a great question. You know, first of all, I should say that was really just the beginning of these studies. The Alzheimer's disease and related dementias are extremely complex. They're very heterogeneous. There are often multiple diseases that present in individuals. In fact, it's sort of rare to have only Alzheimer's disease pathology in the brain. And we really need to understand this variation, this heterogeneity in disease better. This requires actual real population studies to look across many, many individuals and to start to be able to differentiate these different trajectories, which will be important when we get to trying to understand different patient populations and how different people present with the disease or might be treated for disease. So I would not like people to get the idea that we're done with this in any sense. The other thing is that the brain is very large and it has many different parts that are differently affected in disease at different stages in disease. And we've really just begun to look at that. You know, we heard earlier, Justin mentioned the cholinergic drugs that were the first line, that those are affecting the cholinergic neurons, which are in different parts of the brain that we haven't looked at. There are many other parts of the brain that are affected. So this is really one of the huge challenges we have, that we end up, because the brain is so large, we end up with a spotlight and we're looking only in tiny little areas. We really need to get a better picture of what's happening across the brain, across disease, and with the heterogeneity of different combinations of pathologies that we see. So this is really just the beginning, and I think there's a lot more work to do, but we have the tools to do it now. This is now possible to approach this in bigger ways. And I think we can begin to connect the types of things that are now in clinical practice, such as the blood tests and the imaging studies, with these studies of the postmortem brain. These are currently disconnected things. But if we can start to bring these together and we can study the brains or before and after treatment even, or in individuals that have had such treatments, we can start to get to a place where we can predict from the non-invasive tests that can be done in a clinic, the state of the brain and their likely course of disease. And so there's a lot more work to do here. But at the same time, these resources are now here to mine. And I described a tiny, tiny bit of these resources. They're so rich. There are molecular pathways that are affected at different times in disease, in different types of cells, in different parts of the brain. And so we really need to have the whole community start to take advantage of these data and to understand what's really happening, because these could lead to the next set of targets for pharmaceuticals or cell therapies, as I've been describing. I think it's extremely hopeful that we have these technologies and that we can do this, but now, we really have to dig in and understand the spectrum of disease and encourage the community and fund the community to take advantage of that information and take it forward.
Yeah. Sarah.
So I have to jump in and say, so many of the things that you were talking about put in mind the Global Council's work around the science behind music. And one of the things that I remembered is that music is one of the things that affects multiple parts of the brain all at the same time, and that they think that is a theory about why music maintains its power throughout your life and into the brain, even in the latest stages of disease. So I'm curious, and the science needs to continue to develop in that space. But have you given any thought to that?
Well, I think what you're pointing out is really important, that the brain is a network. It's connected in specific ways, and those regions affect one another. And so as a progressive pathology moves across the brain, it will affect different parts in sequence, but also any node will affect many other parts together. And so I think it's really important to be thinking about these functional networks as we think about what's happening. And again, why this is only the beginning of what we've been looking at. We've looked only in a few parts of the brain, but now we can look at these connected parts of the brain and start to integrate this sort of functional understanding with this very micro level understanding of the cells and molecules that are affected. We need to understand the whole system, and this is the nature of the challenge of this, is that it's so complex.
Mm-hmm.
Sarah, you also mentioned music, and we did have one question that I thought was interesting. Tammy asked, is hearing loss unrelated to age still an issue, possibly leading to dementia? I'm assuming that what you're saying is being able to hear that music is what helps stave it off. So is that a yes?
Yeah, so hearing is, the science around hearing is still, and its relationship to the brain is still being studied. I point to Charles Lim's work in auditory receptivity in the brain at UCSF, a variety of many other scientists working in this space. But what we know is there is a association between the loss of hearing, whatever kind that there is, and later stages of cognitive decline as a result of sensory loss. It's not just limited to hearing, but it's the way that the brain perceives information. So that work, no matter what the cause, early, late, whatever, there is a definite relationship. And we know that improving hearing or stopping hearing loss at a certain juncture is beneficial to supporting brain health. So that I can't explain more deeply about the science other than it doesn't matter the cause, age-related or not. It's just incredibly important to protect your hearing and then correct it if you find that you've got issues.
I think one of the
I'm sorry, when I'm in a loud environment and I listen. Justin, go ahead.
I think one of the key distinctions is specifically differentiating, and this might have been part of the question, but differentiating between hearing loss and deafness. It's a critical distinction that if somebody was a normal hearing individual and over the life course has gradually lost their hearing ability, that's different in what we're talking about here than deafness, for example, from birth or early trauma or something like that. And so that's a really important distinction. The way that I tell patients, particularly if I'm interviewing or meeting with a patient and a spouse, and I ask about hearing, and I'm seeing the spouse in the background nodding emphatically, like, yeah, they can't hear. If you can't hear, you're not going to be able to get that information into the memory drawer, first off. But also there's a compounding effect that comes from that, of withdrawing from social contexts, withdrawing from participating in social dynamics and conversations that can really have this synergistic effect on impacting just broader engagement of your brain networks. And so hearing loss, and so especially for hearing loss, where it's as relatively easily addressed as just hearing aids, that can make a big difference.
I want to ask this next question kind of to all of you, because we've actually seen stress affect us at, the cellular level, right? Stress is such a key factor in breaking us down as a human. So Patricia asks, what is the real impact of stress regarding Alzheimer's? Ed, have you seen it in work? Justin, what do you see? And Sarah, what have you learned?
Well, I'm happy to start. Stress is one of those things that certainly can erode cognitive efficiencies. If you are an individual, you have something that's on your mind, or you're burdened, or you're overwhelmed by some external demand that is increasing your stress load, that can really be detrimental. As an example, every individual has a capacity for cognitive functioning. Just think of a pie. And that is almost like your cognitive horsepower, so to say. If a portion of that pie is consumed by stress, worry, anxiety, or something else that is taking away your focus, there's less pie left to dedicate to all of your daily function and the importance of things like activities of daily living or other demands on your cognition. And so from a practical clinical perspective, yes, we absolutely know that there's a relation. I know if I'm stressed or bothered by something, I've got something on my mind, I'm not functioning at my absolute best. And particularly when you start to see that prolonged stress exposure, then I think that you start to see impacts at a cellular level, perhaps, which Ed, I'm sure, can speak to much more eloquently than I could.
I don't know, Ed or Sarah, if you want to jump in on this, but I do have a ton more questions coming in, so we can just keep zooming through them. So Justin, thank you for that. So speaking of networks, John asks, how important are social networks such as book clubs, civic organization, family, friend groups, etc.? Sarah?
Turns out that social isolation and loneliness are key issues when it comes to cognitive health. And without going to too far detail about this, what I want to mention is that the Global Council has done a specific report on social engagement, discussing and thinking about the relationships that people have and their ability to maintain relationships and their brain health across the lifespan. And the science here, I will say, is a little bit tricky because we don't have randomized controlled trials that isolate people and then test their cognitive function. So the studies that we're relying on to address this have a lot of sort of epidemiological evidence around this. But it's funny that we had this terrible time of COVID where we had people who were naturally experiments of separation. And you can see the effect on people was tremendous. Mm-hmm. Now, the Global Council on Brain Health talked about this, and it's a very personalized thing. There are people who can be surrounded by people and still be lonely. It's not just the number of contacts that you have or the type of contacts that you have. It's how you as a person interact and engage with those contacts. But in general, and this is particularly true of the aging brain, as you live and have life experiences, oftentimes your social connections can have be lessened, whether it's because you leave employment or you have a death of a spouse, something like that. It turns out, and that's one of the other things we didn't get to talk about, but AARP is working with the Institute of Health Metrics and Evaluation and the Alzheimer's Disease Data Initiative, both Washington State-based initiatives, where we're looking at comparative effects. And we're talking about some factors of engagement with organizations and the quality of those engagements being very beneficial for your health. So it's not just that you're surrounded by people, but that you're having purpose and that you're using your mind in ways with those types of activities. And whether it's a church or it's a sporting activity, the relationships of people together, acting together, turns out to be very beneficial to the aging brain.
That's so good to know. Thank you, Sarah. I have another question, and this is someone who clearly knows their way around some research. And so, Ed, I'm going to send this one to you. This is from David. He asked if there's a way to get involved in the AAV research targeting specific brain cells at the Allen Institute or elsewhere. Now, I know this is still in early places, but could you kind of explain maybe how our research goes about and how people can help out with what you've kind of mentioned in your presentation?
Sure. So we have active research programs on developing these adeno-associated viruses coupled with cell type selective enhancers, which are sort of this tool now that lets you transduce cells and turn on a gene in just a particular type of cell. This is in large part actually supported by the NIH Brain Initiative as well through a program called the Armamentarium, sort of an arsenal of tools to selectively target cells that might turn into therapies in the future. We have internal programs that work on this. If you're a scientist, there might be positions available for such a thing. But also we make these data and the tools publicly accessible as well. We have recently had a series of publications coupled with a data resource so that all of the tools, the data around those tools is accessible, and they can be ordered even through third-party vendors for research as well. And so there are a variety of opportunities to learn more about this and to use them yourself if you're a researcher, or to potentially get involved. I would encourage you to reach out directly if you have more specific questions about that. But it's a very exciting area that I think is going to upend a lot of parts of medicine, not just in the brain, of course. In fact, the brain is the most difficult place to apply these tools. This has been an area of very active advances in the pharmaceutical industry to develop versions of these AAVs that can be applied through the blood and cross the blood-brain barrier, rather than having to do direct injection into the brain, which is not a favorable thing for most people. This is definitely primed for making big advances in science and in medicine. And I'd be very happy to talk directly if you'd like to reach out.
Thank you, Ed. We have a couple of minutes left. I have one question, Justin, quickly about eyesight. Says this is from Barbara. Says my sis with Alzheimer's couldn't see well. Her doctor said her glasses were fine, but her brain couldn't understand what she was seeing. Is that true? And is that another thing that people should be concerned about?
So that can happen. In fact, there's a very rare variant of Alzheimer's disease that can interfere with the way the brain processes visual information, even though the eyes may be working well. So hearing and vision and touch, for example, are all senses that rely on our ability, our sense organs, to bring in that information, and then the brain has to know what to do with it. And there certainly can be circumstances where the eyes work just fine, but the brain has no idea how to process that visual information correctly. And it is very rare for that to happen. But yes, is it something that I think needs to be a concern or a worry? No, but I would also, just like with hearing, I would say that make sure you're taking care of your eyes and getting your vision checked, and glasses, corrective lenses if needed, are current and up to date. So vision is just as important, although we pay less attention to vision as much as we have hearing loss, for example.
Yeah. Well, we are about out of time, and I just want to say thank you so much to each one of our panelists. I know I learned so much. I'm sure all of you did out there as well. Thank you.
Thank you. It's been fun.
Yeah. So I want to also thank the AARP and BECU for hosting this truly insightful event. And once again, a recording of this event will be available tomorrow on YouTube. It's youtube.com/AARP Washington. Super easy to find. Again, I am so glad that you were with us, and there's always more to come from the AARP. You can stay up to date with the latest brain health information in Washington State on our caregivers resource page, which is aarp.org/caregiverswashington. There's so much great information there. We'll also have links there to the AARP brain health and staying sharp resources and a video, like I said, of today's recording you can find there as well. So dive deeper, learn more about the topics we did today. You can go to our webpage at the Allen Institute. We are the alleninstitute.org, or you can go to the University of Washington's Medicine, Memory, and Brain Wellness Center at uwmemoryandbrain.org. And of course, you can stay up to date with everything the AARP Washington is doing all the time on brain health and so many other topics, especially, like I mentioned, family caregiving, which is such a great resource. All of this is also on our social media channels. You can follow us on Facebook, Instagram, YouTube, LinkedIn, X. AARP is all over the place. So are we with the Allen Institute, and so is UW. So find us all there. Again, if you want more information, just go to the website, AARP Washington, aarp.org/WA. It has been my absolute pleasure being with you all today. I hope you get out there and enjoy the rest of your day.